So this will be your last kind of summative assessment in this unit. The first half one was the circular motion assignment, which you guys did really well on. Okay, there's no reason why you can't do just as well on this one, because really there's only about 3 major topics on it: universal gravitation, satellite motion, and gravitational field strength, and that's it. Okay, just like the first half just had uniform circular motion, vertical circular motion, and artificial gravity. Like, there's really only 3 topics here. Okay, so that said, make sure you look at how many points the question is out of. Okay, it should give you a pretty good indication of how much work is involved for that question. And for some of these questions, there may be more than one way to solve it. Okay, for example, some satellite motion problems may give you enough information to solve it using Kepler or satellite motion. Okay, one or the other. Either way would be fine. Okay, as long as you show your work for it. All right, so for question number 1, it's some information about Jupiter. Okay, it's saying it's this far from the sun, giving you Jupiter's mass. We're looking for the force of gravity due to the sun, or between Jupiter and the sun for that one. Okay, for number 2, they're giving us the orbital period of Uranus. Okay, obviously it orbits the sun and it has its mass there. That should say kilograms, 10 to the 25 kilograms. You may want to add that in there because for some reason it's missing. Okay, find the orbital radius of Uranus. Okay, for number 3, similar question. We're given the period of revolution for Venus. Okay, now that's not to rotate on its axis, that's to go around the sun. Okay, they give us the distance between Venus and the sun and are looking for Venus's orbital speed. Okay, number 4 is asking about an apparatus like Cavendish made. That was that torsion balance. Okay, where you had the 2 lead spheres and the 2 little pith spheres, and it rotated around because of gravity. Okay, so there's an apparatus like that, and it's being used to find G. It gives us the mass of the lead ball, gives us the mass of the small ball, okay, and tells us their separation distance. We're looking for the gravitational force between them. Okay, for number 5, gravitational force between 2 electrons, 1 meter apart, is 5.54 times 10 to the minus 71 newtons. Okay, they're looking for the mass of an electron. Now, just so you know, all electrons are identical. Okay, so this question is asking, or is giving you the gravitational force between 2 identical particles. Okay, think about that when you are solving for it. Okay, number 6. Okay, it gives us some information about Mimas, which is a moon of Saturn. Okay, it has an orbital radius of 1.87 times 10 to the 8 meters. It also looks just uncannily like the Death Star. If you ever Google a picture of it, okay, it's like somebody took the Death Star and put it in orbit around Saturn. It's funky. Okay, it's got this big giant crater on it, and that's like the only thing there. Okay, so it gives us its orbital radius and its orbital period. We're looking for the mass of Saturn from that information. Okay, number 7 is asking you 2 different things, but you need to read this question carefully because there's some units in here that could throw you. Right? So on July 19th, 1969, Apollo 2's orbit around the moon was adjusted to 111 kilometers. Okay, that is an altitude. Okay, because then it goes on to give you the radius of the moon, also in kilometers. Okay, so it gives you the altitude and then the radius of the moon after that, and then gives you the mass of the moon. How many minutes did it take to orbit the moon? Make sure you're giving me this stuff in the right units. Okay, and then what velocity did it travel? Right, I am looking for that in meters per second. Okay, number 8. A SPY satellite has an orbital radius of 2 Earth radii. What is its period of revolution? So we're looking for how long it takes to make one orbit. I often have people ask me this, so I'm just going to say it. The SPY satellite is orbiting Earth, because we don't spy on anybody but ourselves. Okay? And people always, what is it orbiting? Earth. Okay? We're not spying on the Venusians or the Martians or whatever. Okay? We're only spying on Earth. So it's orbiting the Earth, which is why it says Earth radii. Earth for that one. Okay. Number 9. Okay. They give us some information about Mars. and how it has 2 moons. Okay, part A is asking about Deimos, which has an orbital radius of 2.3 times 10 to the 4 kilometers. Okay, calculate its orbital speed. Okay, and then they give us the orbital radius of Phobos and want us to calculate its speed. Okay. And then number 10, this is a net force question. This might be important. Okay, they want to find the net force of gravity on mass 1. There are 4 masses. Mass 1 is attracted to all 3 of the other masses. Okay, you need to find the net gravitational force acting on mass 1. One other thing to keep in mind. This is a square. Each side of the square is 1 meter. That means this distance here is not 1 meter. This is the most common mistake on that question. Okay? Is to say that the radius between mass 3 and mass 1 is 1 meter. Guys, diagonally across a square with sides of 1 meter is more than 1 meter. Okay? Just keep that in mind. All right, number 11 gives us some information about an asteroid that is orbiting the sun. Okay, gives us its orbital radius and its mass, and we're looking for its period of rotation. Okay, and then for question number 12, some more information about Saturn. We're given its radius and its mass, and we're looking for the acceleration due to gravity at its equator, and how many times greater a person's weight would be on Saturn compared to Earth. Okay, I'm looking for how many times greater. Okay, that's what I'm looking for there in terms of how many times greater. I'm looking for times greater, like what would I multiply my Earth weight by in order to get my Saturn weight. Okay. All right, and then for number 13, we've got a ball that's got 1 mass and another ball that's quite a bit bigger. Okay, if the center-to-center distance between the 2 bodies is 0.1 meters, we're looking for the magnitude of the gravitational force between them. Okay, so make sure you read the questions carefully so you're calculating the right things. Okay. Any questions on this? All right. I am probably going to make this due on like the 17th. Okay, that's next week. There's no way I can turn it around and give it to you before your unit exam, because your unit exam is this Thursday, which would mean I'd have to make it due on Wednesday, which is a shorter turnaround than I promised you I would ever do.
Or we can postpone the unit test.
No, we already did. But thanks for your input. Okay.